Disclaimer. Speculative conceptual framework for discussion, not established physics.
An MRF object is an ordered triple consisting of a type 3-1 von Neumann factor M, a physical band B of faithful normal states on M, and a family of von Neumann subalgebras N indexed by a set I. The algebra together with the physical band constitutes the generalized physical object. The collection of relational subalgebras does not add physical degrees of freedom. It encodes the relational contexts through which the physical object is probed and articulated. Individual states omega element of the band B do not represent physical configurations by themselves. Only the band B as a modular stability structure is physically meaningful. This postulate excludes any type 1-like interpretation in which states are points in a convex state space over a fixed kinematic background. Narrow band axiom 0. Relational invariance. The physical band B is invariant under inner automorphisms of M. If omega is an element of the band B and U is a unitary element of the algebra M, then omega composed with the inner automorphism induced by U is again an element of the band B. Modular data as primitive structures. Given any admissible state omega in the physical band, and any relational subalgebra N sub I of M, Tomita Takesaki theory supplies a modular operator of omega relative to the subalgebra N. A modular generator of omega for N, defined as minus the logarithm of the modular operator of omega relative to N. And a modular flow associated with the state omega and the subalgebra N, evaluated at a real parameter T. Relative modular operators and cons co-cycles between pairs of states in the band B encode how modular structure transforms under admissible relational subalgebras. The physical band is defined by the joint satisfaction of three conditions. These do not construct dynamics or geometry. Instead, they select which modular structures are physically admissible. At the foundational level, the narrow band excludes entropic modular singularities of relational structure. NB1 and NB2 represent complementary operational expressions of this single prohibition, constraining informational and dynamical manifestations respectively. Narrow band axiom 1. Entropic stability. For each relational subalgebra N contained in M, the second variation of Araki relative entropy, that is, the relative entropy of omega S with respect to omega 0, restricted to N, along any smooth admissible path omega S in the physical band B is uniformly bounded from above and below by finite, non-zero constants independent of N. This condition endows B with a well-defined modular information geometry and excludes both arbitrarily flat and arbitrarily singular modular response. Narrow band axiom 2. Modular generator control. For each relational subalgebra N contained in the algebra M, consider the family of modular generators. The modular generator of a state omega for the subalgebra N was defined as minus the logarithm of the modular operator of omega relative to N, with omega an element of the physical band B. This family of modular generators varies continuously in the strong resolvent sense. Moreover, admissible variations induce globally bounded spectral flow. The norm of the variation of the modular generator of omega for N is bounded above by a modular constant C, finite and independent of the choice of N. This axiom expresses the narrowness of the band as a restriction on modular energy response. Narrow band axiom 3. Relational gluing. For overlapping relational subalgebras, cons co-cycles relating the modular flows of admissible states satisfy coherence conditions on triple overlaps, up to a bounded phase ambiguity controlled by the same modular constant C. This ensures that modular time and relational comparison are globally consistent rather than locally defined artifacts. The modular width h bar mod is an intrinsic structural parameter of the algebra M together with its physical band B and does not depend on spacetime reconstruction or on effective field descriptions. Effective quantization arises from the existence of a non-zero modular width h bar mod. Discreteness is not fundamental, but reflects the exclusion of unstable relational deformations within a continuous type 3-1 setting.